This lesson is kind of the second part here in our lesson on correlation coefficient and lines of best fit. So what we're going to do here is I'm going to show you how to use your Desmos graphing calculator to find the line of best fit, which remember the line of best fit is just the best trend line for a set of data, and also how to find the correlation coefficient. Remember, that's the number that represents or that tells you how well a line fits the data that it is representing. Before I get started, right here, these first steps at the top, if you would prefer, or at least if you want to see how to use a graphing calculator, a handheld calculator to do this, these are the steps that you would follow. So if you want to try and figure that out on your own, you can, but I think that the Desmos is a little bit more user-friendly, so that's what we're going to use is the Desmos calculator. So our first example right here tells us that the information in the table below shows the average temperature in northern latitudes. So it gives you the latitude and the corresponding average temperature at that latitude. So this is the data that we're going to put in a table. We're going to graph it, find our line of best fit, and all of that using our Desmos calculator. So in this other tab, I've got my calculator ready to go. And the first thing I need to do is I need to input that table of values. So to do that, I'm going to click over here on this plus sign where it says add item, and I'm going to add a table. And in this table, I'm going to put in all of these values. Remember, the first row or column in a table is your X values. So in this case, our latitude is the X and our temperature is the Y. So my first step is I'm going to go ahead and I'm going to put in all of those values. So my latitudes are just increasing by tens. So 0 all the way to 80. And my temperature at 0 latitude was 79.2. And then I had 80.1. Oops. So really, we're just entering in the data from that table. All right, so we've got it all in now. Our X's were the latitude and our Y's were the temperature. So we've got our table, and you might think, well, I don't see anything graphed over there. And the reason for that is we are zoomed in really far here on our graph. We're just seeing like 0 to 10. So we need to zoom out a little bit because we know our X's go all the way up to 80 and our Y's are some bigger numbers too. So I'm going to kind of move over. So I'm looking in the positives, and I'm going to keep zooming out. And you can see our points then start to appear. So our points are graphed for us now on the graph. We didn't have to do anything. Once we put in that table, we just had to zoom out to see it. And now the second thing I'm going to do is I'm going to find my line of best fit. So I'm going to click here. You can see I've kind of got this second line to type in. And we want our line of best fit as a linear equation. And so linear equations, remember, we write them in the form y equals mx plus b. And so what we type in here is going to be very similar to that in order to find our line of best fit. But instead of y and x, the Desmos calculator is recognizing this instead of x as our x1 and instead of y as y1. So we are going to say y1. And I didn't have to do anything special to get that 1 as a subscript. All I typed was y and then 1, and it's automatically going to turn it into subscript there for you. Y1, and then we are going to use this symbol right here. That's right next to the 1 on your keyboard. That's kind of like approximately. Y1 is approximately equal to m times x1 plus b. So this is essentially just slope-intercept form, y equals mx plus b, but we have written our x1 and y1 instead of just x and y, so that Desmos knows to use this table above to find it. And this sign is just saying this line is not exactly equal to the table. It's an estimation. Like we said before, our line of best fit is always an estimate. And you can see that right away, once I typed that in, Desmos popped up this black line. And so that black line represents the line of best fit, or the best trend line for this data. And so it tells us all of the important things about that line that we need to know. The first one is this R value. That R, like we said, R is the correlation coefficient. So for this set of data that we were working on, the correlation coefficient is negative 9.7, or I'm sorry, negative 0.97. And our slope is negative 1.06 approximately, and our y-intercept is 92.3. So we can use that. We can use the b and the m to write our equation, and then we can also find that correlation coefficient right here if we needed it. So I'm going to go back now to our problem that we had, and I'm going to write my line of best fit. So remember, that's going to be in slope-intercept form, y equals mx plus b, and Desmos told us that our m value was negative 1.06, so that's what I'm plugging in. So negative 1.06x plus the b value, which was 92.3, so plus 92.3. So that is the equation of the line of best fit. And then it says estimate the average temperature for a city with a latitude of 25 degrees. So all we're doing here is we are just plugging in 25 for the x value. So instead of x, I'm putting in a 25 plus 92.3. So then when I go ahead and multiply here, negative 1.06 times 25 is going to be negative 26.5. And then plus 92.3 gives me 65.8 as the average temperature for a city with a latitude of 25 degrees. All right. So now that we have done that, the last thing that I want you guys to do here is I want you to try this second problem. So this problem right here, it says the information in the table below shows the Olympic 500-meter men's gold medal speed skating time since 1980. So this second problem, I want you to see if you can put that in your Desmos calculator, find the line of best fit, and I would also like you to find the R value. So see if you can also find the correlation coefficient, find the line of best fit, and estimate the 500-meter time for the 2012 Olympics. So you would be evaluating that for the year 2012. All right, if you have any questions, go ahead and include those in your notes, and I will try to answer them tomorrow.